Alright, so for this lesson, we will be talking about central limit theorem. So where do we use this type of theorem? So at the end of this lesson, you are expected to illustrate and define the sampling distribution of sample mean using the central limit theorem. So as you can see, we'll be talking or we are using the central limit theorem on sampling distribution of sample mean. So this is just a continuation of the previous video. So before going to the lesson proper, let's try to look back on some of the properties of different distributions. So try to answer the following questions. First, what are the properties of a normal distribution? Second, what are the properties of a standard normal distribution? So pause the video for a while, then try to answer these questions. Okay, so let's now proceed with the central limit theorem. So the central limit theorem states that under rather general conditions, the sums and means of a random sample of measurement drawn from the population tend to possess an approximately normal distribution. Okay, sabi niya, yung means daw or yung sums ng mga measurement na galing sa sample, there's a chance na yung mean or yung sum from the sample ay the same sa mean or sum ng population. Okay, as sample size n increases, the shape of the distribution of the sample means taken from the population with mean and standard deviation will approach a normal distribution. Okay, I hope people that you can still remember what a normal distribution is, especially its property, right? So the mean mu sub x bar of the sampling distribution of means is equal to the mean of the population. So in notation, it is written as this. Okay, so then do not be confused. When you saw this one, meaning it is a mean of a sample means. The reason why there is an x bar here, subscript x bar, is because ibig sabihin, itong mu, it represents a mean, right? Ibig sabihin, mean siya ng mga mean pa. Okay? Is equal to the mean. So the mu sub x bar is the mean of sampling distribution of the sample means, while the mean or the mu is the population mean. So ito, nanggaling siya sa mean siya ng mga sampling distribution, and this one is the mean of the population. On the other hand, the variance of a sampling distribution of means is equal to the variance of the population divided by the sample size n. Now, if you have a given variance of population, say this, for you to get the variance of a sampling distribution of means, all you have to do is to divide the variance of the population to its total sample size. Same things goes with the standard deviation. So technically, as a previous lesson, standard deviation is just a square root of a variance. All right. So to further clarify things, let's proceed with the examples. Say samples of size n were randomly selected from a population with means and variance given below. In each case, find the mean, variance, standard deviation of a sampling distribution of the means. Remember, if you have a given data from the population, specifically population mean and population variance, you are able to find the mean and variance of the sampling distribution by using the data from the population. Okay, so take note of the givens and as well as the symbol used on the givens. So for letter A, let's say n is equal to 4, meaning the sample size is just 4. And C mu or the mean is equal to 4.2. So mean ng ano yung 4.2? So you can see there is no subscript of x bar beside the mu. So therefore, this is a mean of the population. Okay? Kapag wala siya nakalagay na x sa gilid, sabihin mean siya ng population. The other hand, this is as a variance of the population as well, right? Now for letter B, we have n is equal to 16, population means 8, and the variance of population is 9. Okay, so for us to compute that, let us recall the formula again. So to compute the mean of the sampling distribution of means, sampling distribution of means, the mean of that is just equal to the mean of the population, while to compute the variance of the sampling distribution of means, all you have to do is to get the variance of the population divided by n. The other hand, computing the standard deviation of a sampling distribution of means, all you have to do is to get the standard deviation of the population and then divide it by square root of n. So for us to proceed, let's go with the Excel. Okay, so I'm gonna zoom it in for you to see it more closely. Right? So I'm just simply put it on center. Okay. Then let me put a border first. Alright. Okay, so you're asked to find the mean, variance, and standard deviation of a sampling distribution of means. So let's compute for the mean. Okay, for number one, rather for letter A, say, okay, so we know that population mean is equal to mean or sampling distribution or mean of sampling distribution of means. So meaning the answer for this is what? Okay, so since the mean here of the population is 4.2, meaning the mean of the sampling distribution of means is also 4 point. Very well. As easy as that. Okay. Next, let's try to compute the variance. So for the variance, since we know the variance of the population, the formula is variance of the population divided by, okay, n. Very good, n. Okay. Now for the variance of sampling distribution of means, okay, so all I have to do is to sigma or the variance of the population divided by n, as easy as that. Or let me just simply enter it manually, 16 divided by 4, that is 4 as well. So meaning the variance of the sampling distribution of means is 4, right? The other hand, for the um, standard deviation of sampling distribution of means, what do we do? All right. So let us get the standard deviation here first. So I'm gonna copy this. All right. So what is the standard deviation if the variance is 16? Remember, getting a standard deviation is simply as getting the square root of the variance. All right. So all we have to do is to get the square root of the variance, 4. Okay. So for us to get the standard deviation of this, of the sampling distribution of mean, all we have to do is standard deviation divided by square root of n, right? So what is the square root of 4? All right, that's 2. Okay, so meaning the standard deviation is 2. So these are the the mean, the variance, and sampling or standard deviation of sampling distribution of means given that n is 4, population is 4.2, variance is 16. Okay? Okay, so for number 2. So let's say this is number 2, this is number 1. Okay? Again, so for the population mean, remember population mean is equal to mean of the sampling distribution of means. So for number 2, what is our population mean? Okay, so that's 8, right? So meaning our mean of sampling distribution of means is 8 as well. They are just simply the same as the mean of the population. How about for the variance? Alright, so let's compute for the variance. So remember, variance of the sampling distribution of means is equal to variance of the population divided by n. Alright, so what is the variance of the population here? Alright, 9 divided by n. What is n? Alright, 16. Okay, let's press it. Alright, that's 0.5625. Okay, let's proceed. Now with the standard deviation, remember standard deviation is, okay, standard deviation divided by square root of n. So what is the standard deviation for number 2? Remember, to get the standard deviation, all you have to do is to get the square root of the variance. Alright, so just simply get the square root of 9. What's the square root of 9? Okay, it's 3. Okay, so now we can now proceed. Standard deviation of number 2 is 3 divided by square root of n. Very good. What's the square root of n here? Since n is 16, the square root of 16 is 4. Very. That's 3/4 or 0.75. Now, I want you to make your answer in decimal form so that you can easily mm, manipulate it later on. Okay? So that's the answer for that. Right? So let's proceed with the next example. Uh-huh. What's that? Okay, so for example 2, let's say a population consists of values 2, 4, 6. So ito daw yung, let's say, we are dealing with numbers. So ang population daw natin ay tatlo lang, no? 2, 4, and 6. Consider all the possible sample size of n is equal to 2 that can be drawn with replacement from this population. Now, calculate the following. Okay? So first, you have to calculate for the mean of sampling distribution of means, for the variance of sampling distribution of means, and for the standard deviation of sampling distribution of means. All right. So, so we did this during the previous video, right? So let's proceed with the Excel, I think. Okay. All right. So for us to uh know how many possible sample do we have here, we have to use the what? Okay, the uh, combination formula, right? Remember that. So in notation, that is 3 combination of 2, meaning you have 3 options and we will pair it by 2's. Okay? So what is the formula for the combination again? Alright, n factorial over parenthesis n minus r factorial r factorial. Okay, very well. So let me rewrite that here so that you will be able to see it again. So 3 combination of 2 is equal to, so the formula is what? N factorial over n minus r factorial r factorial. So let's proceed on that. So n, actually this is n, just like that, nr. No? So let's rewrite it. Let's put the value rather. Okay. Mhm. All right. So what's our n? 3 factorial, right? Very good. 3 factorial over parenthesis 3 minus 2 factor parenthesis factorial 2 factorial. So what is 3 factorial? Okay, 3 times 2 times 1. How about 3 minus 2? Alright, that's 1. So what's 1 factorial? 1 factorial is simply 1. And then times, so what's the 2 factorial? We're doing this at 2 factorial. Alright, 2 times 1. Okay? So simplify that 3 times 2 times 1 is 6 over 1 times 2 times 1 is 2. Okay. That is 6 divided by 2 is very good. So meaning there are 3 possible combinations that we can create using the value of our population 2, 4, 6. So let's list down the possible samples. Remember, okay? First sample is 2, 4. Alright, 2, 4. Next is, alright, very good, 2, 6. Next is, okay, how about 4, 2? Can we write 4, 2? Alright, no. We cannot write 4, 2 here because in combination, again, the principle of combination, 4, 2 is just the same as 2, 4. Okay? Since in combination, arrangement doesn't matter. Meaning, iisa lang siya ng nire-represent. 2, 4, and 4, 2. As well as 6, 2. We cannot write 6, 2 here because we already have 2, 6. What else? Okay, very good. It's 4, 6. Okay? Alright? So, now let's try to get the mean of that. The mean. Yeah. So, what's the mean of 2 and 4? 2 plus 4 is 6 divided by 2. Okay, 3. 2 plus 6 is 8 divided by 2. It's 4. Very good. How about 4 plus 6 is 10 divided by 2. It's 5. Okay. Alright? Now, these means are called the sample means. Kaya nga siya galing sa sample. Okay? Meaning, it came from the sample, that's why it is called sample means. Oh, alright? So that's the reason it is called sample mean. Now, let's try to, alright, so to make it more precise, let me remove that one. And then let me list down the sample mean here, there. And then, of course, I'm gonna copy this. Alright, so from our mean, let's list down the formula. I mean the probability rather. Now, what is the probability of getting 3 from this? So, ilan ba yung 3 dito? Isa lang. 1, remember the formula for the probability, divided by kung ilan yung option mo. 3. Very good. It's 1 over 3. Okay? No, 1 over 3. Let me format this. Okay? So, it's 1 over 3. How about the 4? Alright, 1 over 3 as well. How about the 5? Okay, 1 over 3 as well. Now, there is a way for us to check if this is a true distribution. No? First thing, the value in the p of x should not be less than 0 or should not be greater than 1. So far, there's no greater than 1 here and there's no less than 0 here. They are all 1 over 3. And the sum of the p of x must be 1. So let's try to sum that. See, that's 1. So meaning this is indeed a distribution. Okay? So let's try to get the mean of the sampling distribution of means. So this is now we call the sampling distribution of means. Okay? Now we will try now to get the mean of that. So how do we get the mean again? Okay? Alright, so for the mean, it's x times p of x. So our x here is the sample means. Okay? So let's try to make a column for that. Let me remove this. Oh no, just let it there. So x times p of x. 3 times 1 over third. There we go. Oh, yeah. And then simply drag it down. Alright. But I'm gonna make it decimal for us to make it more like readable or easy to read. Because I know some of you are having a hard time to read fractions. Number. Let's use two decimal places. Okay? Alright. Again, to get the mean, all you have to do is to get the sum of this column. Baka nakakalimutan nyo na ha. Hindi pwedeng nakakalimutan. Okay? Kasi our lesson are connected to each other. Mean of sample, sampling, distribution of means. So, huh. Let me, there, the text right. Then is equal to, right? So, let me just simply move it here. Because we don't need the problem anymore. So, our mean is, get the sum. There you go. It's 4. Okay? So, our mean is 4. Meaning the mean of the sampling distribution of these means are, is 4. So, we already found the mean. Now, let's find the variance. So, for the variance, I hope you can still recall the formula for the variance. No? So, what's the formula for the variance? Let's write it here. Variance is what? Okay, variance mm, is, oh wait, let me put a symbol. Oh, huh? Variance of any distribution. Actually, the formula for the variance are almost the same, no? So it's a summation of what? X minus the what? The mean, okay, the mean. And then what? Square it, then multiply it by what? P of x. Actually, it has to have a bracket here. There you go. So meaning, you produce a column for this, a column that looks like this, and then you get the sum of that column. Okay, that's how you get the variance. Alright? So let's get the variance for this. So let's now proceed with the x minus mean. So x is on the column K, while the mean is consistent 4 minus 4, it's negative 1 minus 4, that's 0. 5 minus 4, that's 1. Right? Next, let's get the x minus mean squared. So meaning we'll be squaring this column or the value here on the column n. So remember, when you say square, you are just simply multiplying to itself, or you can just simply raise it to 2. It's either raise it to 2 or simply multiply it by itself. See, there you go. Okay. Next is, right? Let's copy this. Multiply it to its corresponding probability. Very well. Okay. So that's this column O times the value on. Simply drag it down. Go. Okay. Since we already have the column, that looks like this, all you have to do is to get the sum of that. So the variance, remember, of sampling distribution of means is, let me extract that. Mhm. What? Okay, just simply get the sum. Variance is 2/3. Or you can just simply make it in decimal. I mean, transform it into decimal, right? Okay, there you go. So that will be the variance. Now to get the standard deviation again, standard deviation simply is just a square root of the variance. So to get the SD, okay, all you have to do is to get the square root of this. So that is our standard deviation. Now in two decimal places, that's okay. Okay, so that's how you get the mean, the standard deviation, and the variance of sampling distribution of means. Again, we called it sampling distribution of means because the value of x here came from the mean of the sample. Okay, that's why it's called sampling distribution of means. Okay, so that will be, I think, all for now. So see you on the next video.